Um, Over the course of the next 20 minutes, I will be hopefully leaving you with an impression of how much further we've come in the world of generative AI and the impact that it's had on a stream that affects us all, healthcare. So, as part of this talk, I'll be covering certain phrases. So, it's important to have a common understanding of what they mean in terms of API factory, agentic frameworks, as well as small language models. So, when you think of agentic AI, think of them as an interconnected functional set of components that have self awareness, an ability to take decisions, as well as being able to guide flows to deliver a business outcome with or without human intervention. Like I said, its ability to take decisions comes from intelligence that it gathers from language models. So, here, similar to how we have large language models, think of them as a junior or little sibling, a complex AI systems that are trained to excel at narrow specific tasks. In terms of training data, they have been trained on parameters between 1 and 4 billion. So just to give you a sense of where do you draw the line between small and large language models. And these narrow tasks, such as being able to chat to a user, being able to summarize documents, being able to necessarily glean insights, is what it usually is pretty good at. Now, in terms of facilitating orchestration between these agents and the language models, is the API factory. So API factory facilitates real-time as well as non-real-time interactions between these agents in terms of making sure that it's getting the appropriate knowledge to make those decisions from the language models while keeping harmony with the peripheral infrastructure around this particular ecosystem. This is how real-world applications deliver business value and how these three components can be brought together in making that happen. So just to give you an example, a business process that some of us may have encountered is the process of getting a home loan to acquire a property. As part of that, the applicant would necessarily submit an application form, and along with that, submit documentary artifacts towards explaining their income, assets, liabilities, and any other information that is necessary to be able to state their creditworthiness and also establish it. So, from a process standpoint, these agents are necessarily empowered to process those application forms, um, be able to process those documents that come with it in terms of matching data, matching information present in these forms, as well as gleaning insights from it, trying to identify if there's anything missing or if there's anything that needs more information. And the knowledge in making these decisions comes from the language model. So the language model in this case would be specialized in terms of understanding the mortgage process, understanding what typically these documents contain, and also if there is anything in those documents that it needs to be aware of, what to look for, and so on and so forth. Now, making the transit between these agents and the language model is the API factory. So the API factory in this particular context understands the plan in terms of completing the process, understands what are the set of agents that it needs to invoke in what order in order to deliver value. And it also makes sure that if there are any peripheral components in terms of source systems, it's able to get information from them, populate information into them, all of that being facilitated by this construct of API factory. So now that we have somewhat of an understanding of these components, it's important to know what sort of agents do occupy our enterprise for today, right? So what is the state of autonomy? So we see that generative AI is really improving quickly, and there are new capabilities coming every other day. But it's important to necessarily understand how to grapple with them and how to use them in a given context. So today we have enterprises that start off by using reflex agents. Reflex agents are an example of agents that are that do not have a long-term view or a strategic mindset as such in terms of understanding the entire process to its entirety, but more so focused on specific portions of it. For example, a good example of a reflex agent is a thermostat. A thermostat necessarily takes samples of take samples of temperature of a given room throughout the given day at different points in time, and either chooses to either raise the temperature in terms of heating or cooling based on the threshold as well as the actual room temperature. So it doesn't think how to run this entire facility optimally. It doesn't think how many samples do I take. All of that is pre-configured. All it does is it reacts to external stimuli, and that's about it. From there, the evolution takes the agent down to a rule-based manner. So, for example, if there is a standard operating procedure or there is a specific flow that is pre-coded into an agent, then it works according to that flow. So, a good example of this would be a robotic process automation agent, an RPA bot. That's a good example of how it necessarily works within its guide and necessarily performs that activity. From there, agents have evolved to use deep learning and machine learning concepts such as reinforcement learning to be able to pick up a new skill, make mistakes, earn rewards based on how it performs, and over a period of time pick up that skill. So a good example of this would be AlphaGo. This came around 2016 timeframe, wherein an agent was designed to, which didn't have any understanding of Go. So Go, as you know, is a deeply strategic game with different possibilities, different moves, and it picked up this over a period of time through multiple iterations of trials and errors, and through that reward mechanism, learned the finer aspects of the game and eventually ended up beating the champion. So from there, in 2017, Google came out with its transformer architecture paper. And on the back of that, we had several large language model iterations that came out on the basis of that architecture pattern. We had GPT-1, GPT-2, GPT-J, and that gave rise to agents that could leverage these language models and necessarily be able to plan their course of action. So a good example of that would be the mortgage one that I just talked to you about, right? Wherein it processed the documents based on an understanding of the typical operating procedures around mortgages, and it guided some of these agents to necessarily complete the credit assessment part of the flow. Now, moving on from there, if the agents were not just focused on the text, not just focused on the information that were present in the form, but moves forward towards leveraging computer vision in order to implement this particular feature, then you enter into a world of multi-modal agents, one that does not just rely on text, but also can use other forms of multimedia such as voice and video in order to complete this particular activity. So this is the world that we are in today. However, scientists theorize that in the future, there will be a case where artificial intelligence would evolve to a point wherein we would get general intelligence embedded within these agents, and that will naturally flow into a world of super intelligence in the not too distant future from then. Jan LeCun from Meta, Paul Allen from Microsoft theorized that this is a good 60 to 70 years away, considering the amount of handicap that we have with these agents today. On the right-hand side, you would see some of the value that has come out of our research and that of McKinsey in terms of the value that these agents have delivered as part of issue resolution, as part of automation, as well as helping level up fresh talent with those who've been on initiatives for a period of time and has generated savings at scale for businesses. Therefore, giving you an essence of how valuable these can be in an enterprise setting. So we talked about these individual components such as the API factory, the small language models, and the agents. We've also shown you how these agents have necessarily evolving in the enterprise. Now let's take you through a real-time a use case in the real world. For example, we call it real-time language processing on resource-constrained devices. I've taken healthcare domain as an example of this particular use case. So let me first paint a setting for you to be able to imagine a specific scenario where this could add value. So take into account that you are a part of a remote medical clinic in a rural setting. And this clinic is set up to service the local populace that speak various dialects, far away from typical urban settings. This clinic not only caters to them in terms of understanding specific issues, but also discharging medical care, being able to set up follow-ups, and making sure that the overall scene from a healthcare standpoint is elevated. This particular clinic also runs remote camps, tens or sometimes even hundreds of kilometers away, in order to service the local population there. And with any medical clinic, your typical mode of operation is to fly in medical professionals, administrative staff, in order to service the community. And it's hard to convince people to sort of run this in a sustainable manner. So, with that setting and with that aspiration, um, comes with some constraints, right? So, given that clinic is operating in this particular setting, there is a requirement to provide real-time language translation services. There is a need to understand what the patient is saying, be able to respond to it, gather symptoms, be able to understand what to do, plan follow-ups, be able to reprioritize healthcare in terms of the cases versus less urgent versus more urgent, and so on. But in order to do that, it's also important to respect some of the constraints. Running services in a remote facility in a rural setting typically comes with internet not being reliable, power supply being uninterrupted is not a not a case of reality. Considering the information associated with these patients that are captured, they fall under the personal identifiable information category. Therefore, appropriate levels of data security and privacy needs to dot the landscape at the right level. We need to bring in governance to make sure that all of this is operated within regulations prevalent in the area. Now, imagine yourself as being an advisory consultant on the set in terms of guiding how do I necessarily build software to respond to this sort of a requirement. So, from a solution options point of view, given the advancement of artificial intelligence and to some extent how mainstream it has entered, how about planning for a solution which involves building some of the software, hosting it on a public cloud, and having APIs, leveraging the large language models and having it connected to the medical clinic? So that way, the doctors and administrative professionals on site can use these facilities to be able to respond to what the patients are after. Yeah. But the issues in terms of doing that are with the power situation the way it is, as well as how fragile internet infrastructure that exists. This is probably not tenable, not feasible in the longer term. So, and this isn't something that can help get this project off the can get started off. Yeah. So, in that sense, um, we reach out to the relevant national broadband network facility, and for these kind of scenarios, the typical response from them is to set up a fixed wireless service where there is line of sight from a typical mobile tower onto the medical clinic, and as long as the line of sight is maintained, one could extend 4G mobile services to the facility. But like I said, one of the important aspects of running this camp is to run remote medical camps too, tens or hundreds of kilometers away. And at that point in time, you may not be near some of these infrastructure or these poles, radio towers that can give you extended 4G service. So, given that, this may not be feasible as well. Now, for something that we are looking at to solve the problem, we need to have a software solution that works really well on site, that is adaptable to run probably even offline, that is capable of persisting information in compliance with regulatory authorities, and is able to work by routinely updating remote state and federal health records of these patients. Um, with internet services working both at the clinic as well as at the remote camps. So, in order for that to happen, satellite internet, particularly companies like Starlink, that they offer low Earth orbiting satellites. Therefore, with low latency, they're able to offer speedy internet services both at the clinic as well as the camps. seems like the way to go. In addition to which, we set up the combination of what we just spoke about a little while ago. AI agents that are capable of processing information, that are capable of chatting to the patients, being able to understand what they say, use APIs and small language models to be able to convert, transcribe it into a language that the administrative staff as well as the medical professionals understand, and is able to also put together a plan towards sorting out or putting together a plan towards improving healthcare overall, scheduling follow-ups, triaging symptoms, and so on and so forth. Now, while we have an overall blueprint of a solution, let's see how that onion gets peeled. Yeah. So, from a solution component view, um, my thought process at the time was to have customers interact with a kiosk. This kiosk would have a combination of phones, computers, as well as tablet computers. All of them would have capabilities to run language models. So we've tested out certain small language models. For example, Microsoft P 3.1 Mini is something that we tried running on an iPhone 14 Pro Max, which runs A16 Bionic, and we were able to get a throughput of at least 20 tokens per second running these models on these devices. So the idea was to have an intuitive experience for the remote community members. So as soon as they get in touch with the facility, they would interact it with the screen. They would necessarily be able to talk to it. We would persist that information, convert it into a language, and then have their feedback transcribed into English. And for scenarios where we need a bit more finer tasks, for example, being able to process a real-time upgrade or real-time sorting of their cases and giving it the necessary priority, or potentially having to triage some of their symptoms, then we would get them to work off a laptop computer. For example, the MacBook Pro M3 Max setup is capable of handling both small as well as medium-sized language models towards processing some of these tasks. So having compute and having the capability to understand what the users are saying and be able to offer feedback in a language that they understand, in a dialect that they understand, is the purpose of having this setup. And an API orchestrator such as REST GPT is able to work with these small language models to put together a plan as well as an executor, so that it's able to orchestrate, sequentialize certain APIs and agent flows as per the plan, and is also able to persist some of that information in its local cache in order for some of these features to come to life. We also designed it to persist a version of the electronic health records locally, while having leveraging the API orchestrator to keep the external data sources also up to date over a period of time through periodic updates and intervals. So this combination of running small language models, having an API orchestrator to facilitate knowledge and between the language models as well as the devices, and also to facilitate updates to local electronic health records as well as external sources, but state and federal health territories, being able to triage and also manage symptoms through external services, document progress on some of these cases internally, externally, transcribe it. These are some of the services that we were able to build leveraging the architectural assembly of these components. One of the unique solution elements that we were able to bring through this was being able to ensure offline support. By using some of these devices, the kiosk was able to run on auxiliary power for several hours during downtimes. And given that much of the responsibility was being discharged locally, reliance on external internet was also fairly limited. So with delaying sync with the central data store, we were able to make our first version work very well in this particular use case. And this is, as a design pattern, I see value in solution advisors having this within their toolbox, given the advancement of language models as well as API orchestrators such as REST-GPT. So this gave me particularly a great sense of optimism in terms of future of healthcare, especially using these API-based integration. And one of the things that I can see as a value here is that everything is able to necessarily be able to process on device. So with these small language models, you are able to enable complex language-based processing along with chat on some of these resource-constrained devices, which previously would have required a data center, a large piece of compute to do. From a state and federal health authority standpoint, it is now realistic to expect that they can engage in remote patient monitoring, being able to provide personalized feedback and care from a healthcare standpoint, and also planning for specific interventions when necessary is a big boon from a remote patient monitoring standpoint. Furthermore, triaging symptoms is a huge value that comes in by having this natural language processing based interface. One is able to prioritize cases, one is able to direct patients to appropriate care resources, which previously was unthinkable. Multilingual support is a huge boon, given that remote medical facilities are positioned to cater to populace that speak different dialects. So having these translation APIs interact with the small language models is able to give you real-time services, and also that barrier between the administrative staff and the doctors disappears in due course with this sort of an arrangement. And as an extension of that, we see telemedicine assistance being more prevalent in the near future. It's able to set up, understand the patient's healthcare regimen, set up follow-up meetings, schedule preliminary health and treatment options, and is also able to monitor symptoms over a period of time. So some of these gives a lot of optimism overall in the future of healthcare. And even if you think about it in other industries, right? If you take into account supply chain within supply chain management as part of a remote mining use case within a remote mining town, and being able to assess the kind of materials that they have, being able to assess what is the extent of dependency they have on some of these external sources, and being able to take some of those decisions over a period of time without having to rely on external sources is another extrapolation of how this could help the mining industry. So similar to that, the hope I have as part of this talk is for you to be able to see the applicability of this use case in your domain, and see if this sort of an architectural assembly is able to give you value in whatever that you believe is necessary in terms of advancement. So, but that said, some of the takeaways include when you embrace agentic AI in this manner, it's important to consider the ethical and responsible use of AI in general. So, as part of these preliminary activities in patient care, it's important to note that you will be seeing a lot of new technologies come into the market. Some of these techniques are likely to mature over time, given the lightning pace at which AI is evolving. It's important to run a periodic review, both from a regulatory governance standpoint, as well as maturing technologies to make sure you've got the right assembly. It's also important to consider some of the ethical implications of using these agents in patient care, so as to think of it from a point of view that whatever information that is being processed is personally identifiable. It's important to have, as much as possible, a healthcare professional who is capable of interacting with the locals in their dialect, overseeing this entire transition. This will necessarily help augment the facilities and fee that are given by local doctors, not meant to replace them. So this is meant to amplify the work that they do. And that's how this solution must be seen as well. Now, when you're looking at small language models, they are, after all, a probabilistic setup. They learn over a period of time. Therefore, continuous improvement and validation is vital for some of these to work. It is important that you are able to validate and see that it's providing accurate medical recommendations from a treatment standpoint, and be able to identify and detect that if there is any drift in the kind of recommendations that it's offering. So that testing of the functionality over a period of time, even in production, is going to be crucial for this to work. And also, with the evolving regulatory scene, there may be certain regulations relevant to your geographic region as well as your industry segment that you will need to necessarily adhere to. And that is important for you to think about as part of building this solution, and making sure that it runs to resolve the business process or specific use case that you may have. So, to sum it up, making sure that keeping a clear watch of improvements in the tech scene, improvements in any other evolving regulations that you need to keep in mind. Considering the ethical implications, it's meant to augment and amplify the work done by local doctors, not replace them. You're using language models to, therefore, these language models are also capable of getting some things wrong. So keeping a close watch about the nature of responses that they're giving, and identifying and responding to that drift is important, as well as keeping a close watch on specific regulations that you need to comply with from a privacy and data security standpoint is going to be crucial. Thank you very much. If you have any questions, you have the QR code, so feel free to get in touch with me with your questions, and I'm happy to answer them. Thank you very much, and have a good day.